5.6, independent events. Now, independent events are different from the last lesson we learned on dependent events. So it means that, like just using the example of the ultimate team and the windy day, they have a better chance of winning if it's a windy day because of the different skill sets on the team. However, these questions that are going to be coming up today, they're independent events. One does not depend on another. Today we're going to be talking about rolling a die and flipping a coin. Those two things are not dependent on each other. You're not more likely to flip heads if you roll a 2. They're independent. Now I just want to mention that this is different from mutually exclusive. Mutually exclusive means that there are no kind of overlapping outcomes. So something like drawing 10 of diamonds and drawing a 10 of hearts, those are mutually exclusive because those two things cannot happen at once. However, non-mutually exclusive is picking a 10 and picking a heart card, because there is one heart card that is a 10. So that means that in all the set of all hearts and all the 10s, there is one overlapping. So that's not mutually exclusive. So just a total side note, know the difference between mutually exclusive dependent and independent. Okay, so those three things are important. All right, so let's just go on with dependent events. What I do with probability is I like to draw tree diagrams because I find them very helpful, just to visualize everything that's going on and all the different outcomes. Mokhtar and Chantal are playing a die and coin game. Each turn consists of rolling a regular die and tossing a coin. Points are awarded for rolling a 6 on the die and or tossing a heads with a coin. So 1 point for either outcome, 1 point for both outcomes, and 0 points for neither outcome. So players alternate turns. The first player who gets 10 points wins. So determine the probability that Mokhtar will get 1, 3, or 0 points on his first turn. Now here's the thing, folks. You can only get 1, 3, or 0 points. So hopefully when we add everything up in the results here, hopefully when we add up all of the different probabilities, they should equal 1. So let's just draw this. So first, let's the first kind of leg of the tree diagram will be rolling a die. And the second leg will be tossing a coin. So I'm going to say let S represent rolling 6, and let H represent tossing heads. Okay, so that means that if we say S naught, okay, or sorry, S prime, that means I roll a 1, 2, 3, 4, or 5. And if I say H prime, or the complement of H, we're saying that we're tossing tail. Okay, so this notation is still going to be important. So either you're going to roll a 6 or you're not. And either you're going to toss a head or you're not. So then the probability of rolling a 6 is going to be 1 out of 6. And the probability of not rolling a 6, or the probability of the complement, is going to be 5 out of 6. If you add 1/6 plus 5/6, that's 6/6. So on your first, on the rolling of the die part, no matter what, there is going to be an outcome 100% of the time. Tossing a coin, either you're going to get tails or heads, so the probability of winning with heads is 1/2. And the probability of losing with tails, or the complement of H, is 1/2. Same thing here. If you roll something that's not a 6, you can either roll heads, or the probability of that is going to be 1/2. Or you can not roll heads, but the probability is also just going to be 1/2. So I'm going to highlight how to get 3 points. So to get 3 points, you need to have both outcomes. So that means you're going to roll a 6, and you're going to toss heads. And if we want to get 1 point, it's going to be rolling a 6 and then rolling tails, or sorry, flipping tails. Or you can roll something that's not a 6, but then flip heads. And to get 0, you get neither outcome here. That means that you're rolling something other than a 6, and you're tossing tails. So, the probability of 3 points is going to be the probability of rolling a 6 times probability of tossing heads. It's going to be 1/6 times 1/2, which is 1/12. The probability of 1 point. Now we have to add up these two probabilities here. Okay, it's kind of like cases, kind of. We're going to say 1/6 times 1/2. Okay, that is this journey here. 1/6, so you roll a 6 and then you roll a not heads. Plus, and I'm just going to give this guy a little heart, 5/6, so rolling not 6, but then rolling, but then tossing heads. 1, 2, just so that you guys know where that came from. It's going to be 1/12 plus 5/12, which is 6/12, which is just going to be 1/2. Wow, half the time you're going to get 1 point. That's a cool game. And the probability of 0 points, that's going to be our pink highlighted. So we're going to go down, oh, I should be more descriptive here. Probability of 0 points. So 5/6 times 1/2. Is going to be 5/12. So just so we can have a nice visual here, this right here is for 3 points, which follows along this leg of the tree. This right here is for our 1 point, which follows our blue highlights. And last but not least, and my favorite color, hot pink. For 0 points, we're following this leg. So we have just answered A. Now let's verify the results for part A, and let's explain what we did. So what I want to do is we must add up all probabilities for all possible outcomes. There's nothing else here that that is an outcome. Like there's not all of a sudden another face on a coin, so that we have 3 options here. These are all possible outcomes that we have outlined in our tree diagram. We can say we know it's verified. If the sum is 1, because that represents 100%. So since these are all of the outcomes that are available to us, we know that there are no other outcomes that could possibly happen. So that means if we add up all the possible outcomes, one of these outcomes is going to happen 100% of the time. Not one specific one, but one of these options. One of these. When you add up all the possible options here, one of these outcomes. Either this one or this one or this one or this one. These are the only things that can happen. So that will happen 100% of the time. So let's try it out. Probability of 1, 3, or 0 points. I'm using or, right, because it doesn't have to be 1 and 3 points, one at the same time. Just letting you know that's mutually exclusive. Dun, dun, dun. So we're going to add them all up. 1/12 plus 1/2, which I'm just going to write as 6/12 because I know that my last one has a common denominator of 12 as well, plus 6/12 plus 5/12. 6 plus 1 is 7 plus 5 is 12. So 12 out of 12 times. One of these things is going to happen. Awesome. That simplifies to 1. I think we verified it, folks.